Hello everyone, Scott Lawrence here. Just thought I'd show you some of the work that I've done recently on the RC2014 Z80 computer. I was originally working on a version called the RC2014LL, which has some hardware modifications, but everything that you're going to see here today does not require any of those hardware modifications. The only difference is that this requires a difference to your terminal program because it implements a sort of back channel like a Z modem or X modem like interface from the computer through to the terminal where it is processed and you have access to a mass storage device over the same serial terminal that you're using to communicate with the Z80. Other features of the LL include a full 64K of RAM and a switchable ROM, a boot ROM, but that isn't going to be covered with this video because that isn't necessary for this. Originally, my computer design, the LL, started out with a serial-based SD card storage system, but that ended up being quite cumbersome, and that's why there's this Arduino directory here, because that was going to be Arduino controlled. I've since gone to the current system, which is software only. So all that it requires is a couple of files. If I do in here, this filter, filter.c and filter.h and filter storage, just requires those being integrated into your terminal software, like Llama terminal, which is going to be out soon, hopefully, or into the Pi graphics module, which a lot of people already have for the RC2014. Now with those, you'll be able to access a mass storage system implemented on the host computer that's running the terminal emulation mass drive. So in here you can see this mass drive is where all of the files are going to be loaded from, or at least accessible to. So a couple things here. So first of all, actually let me run it. Bin / RC2014LL. Okay, so we've just booted up, initializing filter. That's just the startup for that thing. It's still I'm still working on it. I don't have all of the layers implemented yet, but I have enough to let basic work. So it's starting up right now with basic ROM and a full 64K of RAM, but only half of it is actually visible. Emu starts up, and there we are, Z80 by Grant Searle, memory top. Okay, so usually from here you'd hit return, and here you are in basic, 10 print hi, run. So there you are, there's RC2014 basic. However, let me quit out of this and run it again. If I do a 0 for memory top, I filter the text echoing back to the terminal, and I use that to determine, oh, hey, you want to actually boot something. So what it does is that when it sees that, it injects running this basic program, or actually it injects typing this in. So if I do ls, right? So if I do a list, you can see that program loaded in. So if you notice here, your program here ready for new program end. So if you just write your program starting at line 100, then you're totally fine. You can use all of these functions. Basically what I've done here is I've added load, save, type, catalog, CD. CD isn't fully implemented yet. Skeleton.base, that's this file right here. And base load, I'll get to that soon. That's a hex loader that I'm working on. And then seconds and dates. So if I were to type run 84, it'll run the seconds command. So that's how many clock ticks have been since 1969, I suppose. So what that basically is it's giving you, that's just a demonstration to show the back channel working, where you're getting the date and the time, run 85. See, here's the date in BASIC on the RC2014. Here it's emulated, but it's still the same thing. But it's getting it from the host. So it's a mass storage device and a real-time clock system. And obviously there be ways to implement setting and getting that time. So I keep doing that. So if I list again, you can see here there's save, load, load, run. So if you notice on line 51, this is what the program is going to be called. So if I type run 70, it will actually save the program that I'm working on. And so on. Let me restart it. So here we are. Okay. If you, yeah, so you can use this as a way to load and save. It's extended BASIC without ever modifying any of the basic ROM. So you can use this to add that functionality without ever changing the ROM on your system. So now, if you notice, I have that baseload.base file. If I type run 83, what this is going to do is it starts a new program. It should look fairly familiar. It's my own version of the user application. So what it does is at first it starts up, types it all in, and then it runs the routine to poke that into memory, and then it calls user 0, and then you're running assembly code. So if I am now not in BASIC anymore, I'm in my own thing. So if I do help, you'll see this, and I've actually implemented backspace correctly, so it actually works, unlike BASIC. The next thing to do, of course, is add in hex support, which right now I just have resetting the whole thing. So if I do a cold start, memory top 0, there we go. So what I basically am doing here is I'm making you can consider this program here from 0 to 100 to be a library, so to extend BASIC. And I intend to always have 50 being all of the setup variables. So what you need to do is type run 50, RG error and 59. Well, that's new. Oh, yeah, because you don't actually have to do that anymore. Yeah, so you can put all of your variable names, like the file name, in there. Then you have the additional ways to load, save, all of that stuff. Do a catalog. There we go. There's all the files on the disk. And all of those I could load. So if I could change the file name, I can load any of those. So that's the first step. Soon I'll have the hex loading routine running, and then the next step after that is to add in CPM loading, which will be kind of cool because then I will have a way to put CPM on this machine without ever having burned a ROM.